Good morning everyone. Myself is Parminder Kaur from Government Polytechnic College for Girls Jalandhar, and my topic is permutations and combinations. Before starting permutations and combinations, we must have the knowledge of factorial. We must understand the term factorial. We start with the definition of factorial. Factorial, how we define factorial? The continued product of first n natural numbers is called factorial n. The notation for the factorial n is sign of exclamation or the sign of angle is fixed to the highest natural number in the product. For example, 5 factorial is equal to 1 into 2 into 3 into 4 into 5, or we can write this as 5 into 4 into 3 into 2 into 1. Now, let us see what is our factorial. It is the continued product of first n natural numbers, and notation used for factorial is this sign of exclamation or this sign of angle is fixed to the highest natural number in the product. We have taken the example of 5 factorial. Now, this is the product of 1 into 2 into 3 into 4 into 5. Now, highest natural number is 5, it means this is the factorial of 5 of number 5. Note, the thing we must remember in our questions is that factorial of proper fractions or negative integers are not defined. Integers are not defined. We do not define the factorial of proper fractions or negative integers. The values that we must remember is value of 0 factorial is equal to 1. Then we know the factorial n factorial is product of first n natural numbers. This is n, n minus 1, n minus 2, so on to 3 into 2 into 1. If we want to write n factorial in terms of another factorial, we can write this as, this can be written as n into n minus 1 factorial. Here we know the n minus 1 factorial is a product starting from n minus 1 ending with 1. Similarly, we can expand it further. We can write n factorial as n minus 1 into n minus 2 factorial and so on. This was all about the factorial. Let us do one question. The first question, write down the statement: if n plus 2 factorial is equal to 20 times the product of n factorial, then find n. Solution, we have what we have, n plus 2 factorial, this is equal to 20 times n factorial. Now, how we solve this? We expand n plus 2 factorial in terms of n factorial. We can write n plus 2 factorial as n plus 2 into n plus 1 into n factorial. This is equal to 20 into n factorial. Now, on the both sides we have n factorial, cancel n factorial from both sides. On the left hand side we are left with the two terms n plus 2 into n plus 1. Now, we open the brackets, first we multiply n plus 1 with n and then with 2, we get n square plus n plus 2n plus 2, and we have 20 on the right hand side. We take this to the left hand side. When we take right hand side term to the left hand side, it changes its sign. 20 is positive, when we take this to the left side, it becomes minus 20. This is equal to 0. Now, this is n square plus 3n minus 18 equal to 0. What we have to do? We have to make its factors. We can write this as n square plus 6n minus 3n minus 18 equal to 0. Now, from the first two terms, we can take n common, inside we get as n plus 6, and out of these two terms we take minus 3 outside, and inside we get as n plus 6 is equal to 0. Now, what we have, factors we get as n minus 3 into n plus 6 equal to 0. Now, this is the product of two terms. Product of two terms equal to 0 means either the first term equal to 0 or our second term is equal to 0. The first term equal to 0 gives n is equal to 3. Second terms give the value n is equal to minus 6. We are to reject it. Why we are to reject n is equal to minus 6? Because n cannot be negative. We cannot define factorial of negative numbers. N cannot be negative. Therefore, the answer is n is equal to 3 is our answer. Now, once again I explain how we have done this question. We were given n plus 2 factorial is equal to 20 times n factorial. In the first step, we expanded n plus 2 factorial in terms of n factorial, cancelling n factorial from both sides. Then we get the equation quadratic, we made the factors, we were left with n minus 3 into n plus 6 is equal to 0. These give two values, n equal to 3 and n equal to minus 6. We have to reject the negative sign value because n cannot be negative. Therefore, n is equal to 3 is our answer. Now, let us come to our main point. The topic is permutation. We know it will be easier for you to understand what is permutation. The term, the word permutation stands for an arrangement. What does permutation stands for? It stands for arrangement. Arrangement. We define the permutation as a permutation is an arrangement The arrangement that should be in a definite order, of a number of things, taken some or all at a time. At a time. What is permutation? It is an arrangement in a definite order. This is very important. The arrangement that should be in definite order. What we are to arrange? We are to arrange things. We can take all the things at a time or by taking some or few of them. And notation for permutation is NPR, or we can write this as P outside in the bracket. We are taking n things, the total things are n, and we are taking r out of them. We can write this as P n comma r. Now, let us write some results that are going to be used in our questions. The results are: first result, the value of NPR. This is equal to n factorial over n minus r factorial. That is, what does it mean? Number of permutations of n different things taken r at a time. R at a time. Second result, the number of permutation, of n different objects taken all at a time, is NPN, and value of NPN is n factorial. This is our second result when we take all the permutations. Now, result number 3, the number of permutations of n different objects taken r at a time when each object may be repeated any number of times. These are 3 results. One more result we have to write. Fourth result, the number of permutation of n different objects taken all at a time when P of them are alike and of one kind, Q of them are alike and of second kind, all other being different. is n factorial divided by p factorial into q factorial, where p are of one kind and q is of another kind. We divide this with total n factorial. We are going to use these results in our questions. Now, let us do the first question of permutations, that is, if NP6 is equal to 30 times NP4, then find N. What is question? The question is NP6, this is given to be equal to 30 into NP4, and we are to find the value of N. Here we are going to use our result number 1, the value of NPR we know very well. What is NPR? This is n factorial over n minus r factorial. Now, here instead of 4 it is 6. We apply this result, this we get as n factorial over n minus 6 factorial is equal to 30 times NP4, it means n factorial over n minus 4 factorial. Now, we see on the both sides we are with n factorial, cancel n factorial from both sides, cross multiply, we get n minus 4 factorial as 30 times n minus 6 factorial. Now, how we will solve this? We expand n minus 4 factorial in terms of n minus 6 factorial by reducing each term by 1. We get this as n minus 4, n minus 5, n minus 6 factorial is equal to 30 times n minus 6 factorial. Now, on the both sides we are with n minus 6 factorial, cancel n minus 6 factorial from both sides, then we are left with n minus 4 into n minus 5 is equal to 30. Open these brackets, we get this as n square minus 4n minus 5n, minus 4 into minus 5, this will be plus 20. We take 30 from the right hand side to the left hand side, it becomes minus 30 equal to 0. Now, equation is n square minus 9n minus 10 equal to 0. Now, we are to make it factors, make factors n square minus 10n plus n minus 10 equal to 0. Now, from the first two values we take n outside, inside we get as n minus 10, from the last one common, n minus 10 equal to 0. This gives n plus 1 into n minus 10 equal to 0. Now, the product of two terms equal to 0 means the first term 0, that is n is equal to minus 1. We are to reject it, rejecting. Why we are to reject? Because n cannot be negative. Therefore, n is equal to 10 is the answer. Now, let us repeat quickly its steps. The question was NP6 is equal to 30 times NP4 and we are to find the value of n. We apply this formula NPR, we get with n factorial on both sides, cancel n factorial from both sides, then cross multiply n minus 4 factorial, that comes out to be 30 times n minus 6 factorial. From these two we expanded n minus 4 factorial in terms of n minus 6 factorial, cancelling n minus 6 factorial from both sides. The equation is n square minus 9n minus 10 equal to 0. Solve this by taking factors, making factors, we get the two values, one value as minus 1 and another value as 10, reject n equal to -1 because we cannot define factorial of a negative number. Therefore, n is equal to 10 is our answer. Now, let us do one more question. Statement, write down how many different arrangements can be made from the letter of the word engineering. ENGINEERING. Now, let us read once again the statement. What is statement? We are to find different arrangements that we can make from the letters of the word engineering. Now, we know the total number of words in engineering is ENGINEERING. If we count all these letters are 11 in number. Now, in this engineering word E, look at E, how many times it is being repeated? 1, 2, 3. E is being repeated 3 times. Then N is also repeated how many times? 3 times. We write E and N are being repeated thrice. Then come to G, word G, here is G and 1 here. G is being repeated how many times? 2 times. Similarly, I is being repeated twice. G and I, they are being repeated twice. Therefore, total number of arrangements, here we are going to apply the last result we have written, the fourth one. Total number of arrangements will be, total n factorial is 11. G, E and N, these are repeated 3 times, 3 factorial into 3 factorial. Then G and I, they are repeated twice, double into 2 factorial into 2 factorial. Now, how to solve this equation? Let us say we are 11 factorial, 3 factorial into 3 factorial into 2 factorial into 2 factorial. What we do? We expand 11 factorial in terms of 3 factorial. We can write 11 factorial as 11 into 10 into 9, 8, 7, 6, 5, 4 and 3 factorial as such. In denominator we have 3 factorial, one write 3 factorial as such. Another second factorial 3 factorial can be written as 3 into 2. 2 factorial we know is 2 into 1. One more 2 factorial, that is 2 into 1. Now, cancel 3 factorial from numerator and denominator. We have 3 into 2, that is 6. Cancel with 6. 2 into 2, 4. Cancel these with 4. We are left with 11, 10, 9, 8, 7 and 5. Multiply all these terms. First multiply 11 by 10, then by 9, 8, 7 and 5. We get the answer as 277,200. This is how we can find the total number of arrangements that we can make from the word engineering. Let's do one more question. Write down the statement. Find the number of different 8-letter words formed from the letter of the word the word is given as equation, EQUATION, and condition is if each word is to start with vowel. Let's read once again the statement. We are to find number of different 8-letter words that we can frame from the word equation. Condition is of forming new words from the word equation is that each word that must start with vowel. Now total number of letters in the word equation are 8. Total number of vowels, we know there are 5 vowels, A, E, I, O, U. Out of these, in the word equation we have the vowels as the first vowel is E, then U, then A, then I, and then O. We count these all the vowels, number of vowels are 5. Now we are to frame the words from these, the word that we are to form that must start with out of these 5 vowels. It means the first place can be filled up in 5 ways, and other 7 places can be filled up by remaining 7 letters in 7p7 ways. Therefore, required number of ways, we know the first place can be filled up in 5 ways. The remaining 7 places can be filled up from the 7 letters in 7p7, that is means 7 factorial. We know the value of 7 factorial is 7 into 6 into 5 into 4 into 3 into 2 into 1. When we multiply all these numbers, we get the answer as 25200. This is the answer, means from the letter equation we can frame how many words that each word start with the vowel is 25200. Now let's come to the next point, that is let's explain there is circular permutations. Circular permutations. What are circular permutations? When we arrange the objects, along a closed curve, that is a circle. That is a circle. The permutations are known as